All right, so fully before we move into the concept of Rolle's theorem, there are two concepts that I want you to understand. And what are these two concepts? The first one is the concept of continuity of a function, while the second one is the concept of differentiability of a function. When is a function said to be continuous? And also, when is a function said to be differentiable? Let's start with the continuity of a function. A function f of x is said to be continuous at the point where x is equal to a if these following conditions are satisfied. If f of a exists. 2. If the limit of f of x as x tends to a also exists. And 3. If the limit of f of x as x tends to a is the same thing as f of a, then you conclude that that function is continuous. Let's take a look at this example. Check if f of x that is defined as x squared minus 3x plus 2 is continuous at x equals 1. Let's check if this is continuous at x equals 1. What are the three conditions that must be satisfied? Number 1, you need to check if f of 1 exists. Yes, f of 1 exists, and the value is 0. Also, you need to check the limit of f of x as x tends to 1. That's the same thing as the limit of x squared minus 3x plus 2 as x tends to 1, which is the same thing as 0. The third condition that you are going to check for is that is the limit the same thing as f of 1. Is condition 2, the results that we got in condition 2, is it the same thing with the one in condition 1? Yes, 3 conditions are satisfied, so you can conclude that this function is continuous at x equals 1. Now, let's look at an example. Let's look into this. What if the function is a piecewise function? For instance, f of x equals x squared when x is less than 2 and 3x minus 4 when x is greater than or equals to 2. This is a piecewise function, and in this case, you check for the limits on the left-hand side of 2. Since this part is considering the left-hand side of 2, that is x is less than 2, the values before 2. So you will be using this formula. Check the limit of this as x tends to 2. That's on the left-hand side of 2. And what will this give us? This is the same thing as 2 squared, which is 4. You also test for the limit as the right-hand side. the right hand side. This formula considers the right hand side of 2. That is, it considers 2 and the values above 2. So x positive now, the limit. So you are making use of this formula. If you slot in 2 minus 4, your result will be 2. Since these two limits are not equal, it is not continuous. So knowing fully well that if you check the original value for the original formula, that is f of x for 3x minus 4, you will get 2. So for it to be continuous, everything must be 2. That is, this must give us 2, this must give us 2, and this must give us 2. Since these two are not the same, then the function is not continuous. Let's look at differentiability now. When do you say a function is differentiable? A function f of x is differentiable at x equals a if the derivative exists. That is, if f prime of a exists. So if this exists, then the function is differentiable. So if the derivative of the function, when you slot in a into the derivative, exists, then the function is differentiable. Also, take note that a function that is differentiable is continuous. So, but a function that is continuous is not always differentiable. Is this function differentiable at x equals 5? Is it differentiable? This is all you need to do. What is the f prime of x? That is the derivative of f of x. And that's 2x plus 2. Then slot in the value of f prime of 5. And that's 10 plus 2, which is 12. Since this exists, then it is differentiable. In fact, every polynomial function is differentiable at every point. It is differentiable at every point. Take note of that. Another example, you just need to understand the concept of continuity and differentiability before we move to the Rolle's theorem. Let's consider this piecewise function x squared 2x minus 1, x squared when x is less than 1, and when x is greater than or equals 1. Let's test the differentiability at x equals 1. Is this function differentiable at x equals 1? All you need to do is to check the continuity. After checking the continuity, then you check the two derivatives. Now, to check the continuity, don't forget, is a piecewise function, so you go for the limit as the second condition. The limit as x tends to 1 on the left-hand side now. On the left-hand side, we are considering this formula because this one is treating x less than 1. That is, every value of x that is less than 1 on the left-hand side. On the left-hand side. So this will give us 1. Then if we test the limit on the right-hand side as x tends to 1, as on the right-hand side is considering this. So this gives us 2 into 1 minus 1, which is still 1. So it is continuous. For these two to be the same, it is continuous. If you check the original value, that is f of x at 1 now, is still 1. So this function is continuous. That's the first step. You can call this step 1. You check for the continuity. Then step 2, you check for the derivative. This is the function x squared. When you differentiate x squared, what do you have? You have 2x. When you substitute the value of x, which is 1, you have 2. And when you differentiate the other parts as the second formula, you have 0. You have 2. You have 2. That's f prime of x equals 2. So since the two are the same, you get 2 here, you also have 2 here. So it is differentiable. So in conclusion, we can say that f of x is differentiable.